Hello, everyone, and welcome to our webinar on unmanned aerial systems, specifically with respect to emergency management of flooding. My name is Caitlin Friesman, and I am an adjunct professor with Iowa State University, and I will help moderate this webinar and assist with questions and answers after the presentation has been completed. Also on the line is Robin Murphy, Raytheon Professor of Computer Science and Engineering at Texas A&M University and Director of the Center for Robot Assisted Search and Rescue. Implementation of UAS by transportation agencies allows for increased safety and efficiency while saving time and money for taxpayers. The purpose of this webinar is to provide our partners with the latest technological advancements when using unmanned aerial systems, specifically for the purposes of emergency management before, during, and after flood events. As such, the bulk of today's presentation will be given by our subject matter expert, Dr. Murphy. This webinar is sponsored by the FHWA, whose mission it is to serve our transportation agencies, state DOTs, locals, tribal nations, and federal land management agencies. As we begin, I want to share a few housekeeping items. First of which, we are recording this webinar so that it may be replayed later. And during this presentation today, we ask that if you have questions to please type them in the chat pod. We will then answer all questions at the completion of the presentation. So a few general slides here before we get into the technical presentation. As you're probably aware, since you registered for this webinar, unmanned aerial systems is another term for drones, which are multi-use aircraft that are controlled from a licensed operator on the ground. And they're often coupled with sensors, including high-definition cameras. And they can be used for a variety of applications, but the focus of the Everyday Counts initiative focused upon these three main topics of structural inspection, construction inspection, and emergency response. So as part of our implementation efforts for EDC5, we developed tech briefs and webinars, and it's a four-part series. The first one is today's webinar, which has a corresponding tech brief. That will be posted online soon. So you can read the full tech brief, but the content from today's webinar focuses upon what is covered in that tech brief. There will be 3 more webinars and corresponding tech briefs that are coming up, and those topics are construction inspection, surveying, and bridge inspection. As part of the EDC5 summits, there were presentations on a variety of use cases aside from those highlighted on this slide. And so the link here would take you to presentations on those other topics that will not have a specific webinar, but there's still detailed information on use cases, again, other than these 4 selected topics. But with that, today's topic, again, is UAS for the emergency management of flooding. And the rest of this presentation will give by our subject matter expert, Dr. Robin Murphy.
Howdy. See, get control of the slides here. I'm going to be talking about floods and the use of small unmanned aerial systems for floods, the #1 disaster in the world, in the United States as well. So just a little bit about my background. I'm at Texas A&M, which is one of the largest universities in terms of size, with nearly 70,000 students, but also in terms of engineering research dollars that we bring in. And if you're not familiar with it, we're basically 2 hours from Austin and 2 hours from Houston, kind of in between those. But what makes Texas A&M special, to me, at least in this case, right? Let's see. Okay, there we go. Is that it's a leader in disaster practice. Our engineering extension service trains over 240,000 people each year in emergency response. And this is a picture of Disaster City, which is my favorite place on earth. It's 100 acres of all types of disaster mock-ups, of props, collapsed multi-story buildings, rubble piles, all sorts of things like that. And so it gives us a great place to try out new things. Now, I'm also with the Center for Robot Assisted Search and Rescue, which has been around since 2001, and we've pioneered the use of small unmanned aerial systems for disaster response. We had the very first flights of UAVs for a system for a disaster, which was Hurricane Katrina in 2005. And so we've had a total of 14 responses, most recently Hurricane Michael. We've had several floods and different land movements and other types of events. So when we think about small UAS and floods, you probably have some questions. And it's like, what does we actually mean when we say small unmanned aerial system? And then how can they actually be used for floods? And what are the hidden costs or surprises? Because we all know, right? We all know there's no such thing as a free lunch. Something good, but is it worth it? What's the cost benefit? So we'll talk about that as well. We're going to use this by taking examples of Fort Bend County. Fort Bend County is a suburb of Houston. It's had 2 regular floods, which is pretty kind of extreme to think of when you think they were both presidentially declared disasters. And the Brazos River runs through Fort Bend, the length of Fort Bend County, and then into Houston, which is part of the problem with Hurricane Harvey. So we had 2 major floods in April and May of 2016, and then a year later we had the Hurricane Harvey, which was primarily a flooding event. And it is now tied, Hurricane Harvey is now tied with Katrina for the most costly hurricane in U.S. history. What's interesting is that Fort Bend County, their Office of Emergency Management, after we helped them in the 2 April and May floods in 2016, started their own unmanned aerial system program. And then when Harvey had, they brought in us to help because they're experts. They didn't want them to have to spend all their time flying the UAVs and taking care of the batteries and doing any minor maintenance. They just wanted to look, point, go, yeah, they're there, got it, and make their decisions. So they're really an informed group of emergency managers to look at and how they chose to use the UAVs. It wasn't just a matter of a university or a group of university teams or volunteers coming in and telling them what to do. It was exactly what they knew, had learned the hard way how to do. And just again, they are the 10th largest county in Texas, and remember, everything in Texas is bigger. So The Center for Robot Assisted Search and Rescue at Texas A&M's Engineering Experiment Station has been working with Fort Bend County Office of Emergency Management to provide small unmanned systems, aerial vehicles, and even marine vehicles to be looking at the underneath bridges and the river. What we've been doing is providing small unmanned aerial systems primarily to give aerial imagery so that the officials can see what they're doing to make real-time decisions.
We believe this is the largest formal deployment by public officials of small unmanned aircraft systems for disaster response in our nation's history. These drone platforms working from different elevations have provided our local emergency management team with aerial photography at multiple scales and in high resolution. We have the ability to adjust unmanned aircraft flights in real time to assist with search and rescue operations or changing flood conditions. The teams were comprised of federal, state, and private organizations and agencies from across the United States, all working together to help the citizens of Fort Bend County, Texas.
So that gives you an idea of the UAVs that we were using there. And so let's talk about what that means by small UAS from a practical standpoint. So, as with anything, right, everything has a trade-off. So you think of the satellites are great. They have a larger area of coverage. You think of Civil Air Patrol, they have good area of coverage. As you start going to those little small things at the very bottom, what we call man-packable small UAS, the ones you can put easily in a backpack, you start seeing they run into, they don't cover as much, maybe a mile of area. So it's a much smaller patch. But at the same time, they're very cheap on a level of $1,000. And you've got the data. You're flying it. You're not waiting for a satellite to realign. You're not waiting for anybody to give that information to the State Operations Center, who will eventually get it to you, the internet willing. Okay? And so your ability to control, the better resolution, the low cost, is a really positive trade-off often with coverage. You can make do with seeing a few things. Now, the FAA considers small UAS. They don't have to be restricted to 400 feet. There's a type of license, the Part 107. 400 feet makes it very easy to control manned and unmanned airspace, so they like that. But for instance, they consider small can be that large one that you saw, that the in situ Scan Eagle, that's a catapult launch, takes an 18-wheeler to bring all the gear for that in. And you launch it and then you do the arrested stop. Okay, so that one actually goes at the same altitudes as a small Cessna can. So it gives you a lot of coverage, but it may not be particularly useful, since you could probably get the Civil Air Patrol to fly the same area and with a lot less coordination effort. So really what you're looking at is a smaller coverage area, but with very rapid, short time, but with a very rapid turnaround on information. Okay, so the question then becomes, you can have small, and they can either be fixed wing or rotorcraft. Fixed wing means it looks like a plane. Rotorcraft means it looks like a mutated helicopter, a multi-rotor helicopter. And you see a M600, the bigger ones can carry lots of gear. A lot of times these were developed for the entertainment industry to carry very expensive cameras. And then the Mavic Pro, which is kind of a prosumer. It's a consumer model, but it's so good you can use it to do everything that big M600 does. So how can these small UAS, let's talk about the ones that are in the $1,000 to maybe $30,000 range. How can those be used for floods? So let's look at this from the first two floods with Fort Bend, the 2016, the merely presidentially declared disaster ones. So the things they were starting to use is that even if they couldn't measure the flow rate, they could get a good estimate of how much the flow rate was back in areas that they didn't even realize were being flooded. You couldn't see back behind the trees. They were looking between the trees going, holy moly, there is water in there. We didn't have no idea there was water that far back. And so looking at that specular reflection gave them a much more accurate understanding of how much water was there. They were able to look at all their neighborhoods and McMansions that are coming in, what the water was. They were also able to document, okay, that developer didn't get the drainage right. They didn't do that, different things. So they could monitor the situation pretty well. And then looking at critical infrastructure, everybody gets in and out of that county to Houston over a bridge at some point. And so starting to be able to look at that and get a sense of how much is building up on the bridge, whether we're seeing any signs of problems, is a big deal. So let's talk about data products. So how are you going to use them? Well, how actually, is what data do you expect to get from them? You get, usually every UAV will provide you video and stills. And then whether or not these are thermal images, that's another payload you can get. But you always get at least regular video and high resolution imagery. A lot of people like to take that. Well, all of the data can then be, for most of these UAVs, almost every commercially sold UAV now has a package that takes images in such a way that it makes it easy to tile them together into an orthomosaic, one of those big maps like NASA does of Mars, where they stitch everything together. And you can also use that to get a pretty darn good digital elevation map. And in some cases with 4 centimeter or less per pixel accuracy, although technically to get that you need to have some anchor, some surveyed anchor points in the image that you can then reference to. But usually you can tell the drainage pretty darn well. And these tools, these data products pop into Esri. Almost every emergency management organization is using some of Esri's tools, and of course you can pop them into Google Maps, whatever you're using. But now you can start using this to see the before and after and start measuring differences. Also, the MIDI packages give you the ability to control what you're actually seeing. So the quadcopter could have flown just this narrow corner here of this neighborhood, but a lot of times you can fly it that way, or you can have it automatically exclude regions if you're worried about privacy. So another thing is that how can you use them would be when to fly, and every chance you get, it's going to be answered. Certainly during the prevention and preparedness, you may not be thinking of flying, but that's actually a good time. Flying periodically so you understand what's going on, flying immediately before the event or suspected event. I believe it was in the April floods that Fort Bend discovered that one of the developers who was building the neighborhood, huge, one of those mega neighborhoods, was still under construction, but they hadn't completed all of their levee system and drainage system. So what was going to happen is that they could tell it wasn't going to flood, the neighborhood wasn't going to flood, but there was no way to get in and out of the neighborhood, which is great if people never need to go to the grocery store, but also people in that neighborhood could have babies, they could have heart attacks, they could have any kind of medical problems, and you couldn't get paramedics into there. So the county was able to very quickly build a dirt road ramp that was good enough to get a ambulance over to it, so they could get in there if they needed to. So it was letting them be prepared and prevent any problems. And that also gets in the fact you can do your digital elevation maps. When to fly. Also during, the obvious time is during the actual event, the response, both flying for tactical reasons for the people using, on boots on the ground to make decisions, as well as the overall management process. So for instance, tactically, you may be flying for overwatch and safety. Common thing that we saw is you're flying initially to help the responders. They don't need to find where people are on the houses because the cell phones are working at Harvey well enough for them to do it. It's like, what's going to be the fastest way to put the boat in? Do we go this way, or can we take that road that's not flooded up there and that's actually going to be shorter? So those kinds of things. Recon of the situation. Particularly what you see is flying the vulnerable spots or statistically sampling. The emergency managers, you often know where the weak spots are. And I think this is true with the highways. You kind of know the areas that most likely get flooded, and you go check those first. You don't need to check the parts that you are pretty sure are okay. You prioritize. In the case of a flood, you can fly hourly, even every 15 minutes, day and night, to monitor the flood levels, which is what they were doing a little bit in Fort Bend to monitor the whether it was going to overtop the levees, in part because it turns out that one way you know you're in a flood condition is when the flood gauges become flooded and not useful. So kind of counterintuitive, it seems like. Anyway, so being able to monitor is a big deal. Okay, let's back up. And we want to fly mapping missions as needed, although you'll see there'll be more time later on. And we want to inform the public, we'll talk about that as well, and document violations for later, like a development or drainage wasn't right, or there was a problem, or something came up. It's pictures worth 2 months in court, is what I've been told by engineers civil engineers who've had to deal with insurance companies and construction lawyers. Okay, so when to fly. Next part, recovery and reconstruction, right? That's an obvious time as well. That's when you've got everybody back in. Now the insurance companies are coming in. You want to do your detailed mapping. You want to monitor your reconstruction, and also to post progress to the public for what you're doing. Next. So if you look at Harvey by day, the 2 weeks that we were flying for Fort Bend County, you see a little bit before, a little bit during the incident, and you didn't see really start flying to the 31st, and that's because it rained the whole darn time for 4 days. So not only you have your initial rain, and then you have all the water draining from upstream on top of it. So we really couldn't get to the sky until about the 31st to start flying. You see, mostly inspection, damaged debris, making sure you knew what the extent of the flood was so you could get the federally declared disaster and trigger resources that you needed. And then later on, all your mapping missions and things came, which are in green, started coming later. You didn't need to, you started filling in the gaps off of your prioritization, and that'll make more sense. Just a minute, right? So let me emphasize that probably the best strategy is to do rapid spot sampling, not I'm going to get 100 UAVs, put 100 people out there, and we're going to map the entire county. Instead, you're flying basically your trouble spots, your vulnerable spots areas there. So in the April and May 2016 floods, we had 21 flights at 17 locations. And they were short flights. Notice they're average 10.4 minutes because the experts were popping up. Look, you see, yep, got it. This is mapping. This is following the flood inundation map. Exactly what we thought. Oh, no, it's not mapping. It's not following the flood inundation map. Why is it not draining the way it's supposed to? Can you fly? Keep going up there. Oh, look, up that creek, there's something blocking it. We got to get somebody in there. There's a log jam. We got to see if we can get back in there and bust that open. Harvey was a record-setting number of flights, 112 flights, 56 locations, and again, short flights. Just keep in mind the travel time, the locations, because all the roads were flooded, was 2 to 4 hours. And that'll make a difference when we think about manpower and planning. So again, spot sampling, and you can see kind of on the map just how spotty it was rather than just a complete systematic mapping of the entire county. And it's inexpensive to do that. I mean, it's practically free. So next slide. Okay, so why not those photogrammetric surveys? I mean, why not? Well, was the FAA with their beyond visual line of sight saying you've got to keep a UAV in line of sight? All of these was it a regulatory problem? No, it turns out that orthomosaics and digital elevation maps just weren't a priority. They either had that from beforehand or they can get it from a manned fixed wing, which were flying for the state. It's hard to do orthomosaics when there's moving water. So if you were trying to do that on the fly, you were sending us out to do an orthomosaic, and there was flood waters, it wasn't gonna do well. And plus, the Office of Emergency Management didn't need it. They needed to see their priority items, not the entire county. And when you're starting to stitch these together, you wind up with files that are on the order of 50 gigabytes, and you can't email them. You're having to take thumb drives from person to person. If you're doing a digital elevation map, no one can look at it because it's a 3D simulator and you have to do these weird keyboard motions. It's really built to, if you have a joystick for a game, which is a lot of emergency managements don't have gamer joysticks sitting there. And then there's all sorts of, a lot of the processing is usually done over the cloud with a license, which nobody has the license, and they're very expensive. So it just isn't worth it. So we typically don't see that until the response to the recovery phase where everything's settled down, and now we're going to go back and do that systematic look. Next slide. Missions. We always get asked, and we've done floods in several states now, and it's like, oh, we want to see the water level in the house. That turns out to be great, right? If you know the water level, if it's 6 inches, 18 inches, makes a huge difference in the disaster response. It also makes a huge difference in the type of trash you're going to get, whether you have to take all the sheetrock and all the electrical wiring out how long people are going to need assistance, that sort of thing, which is great. It turns out, though, that it's pretty hard to tell. People like to build their houses by trees. So if there is a way for the tree to be in the way of you getting a good assessment of where the water is versus where the windows are on the house, or get some estimate that way, it will be there, let me assure you. But you can quickly see that water is touching that house, and that's usually enough to quickly get a county or municipality to meet the disaster funding status. Next slide. Okay, what we do see more value in is flood mapping and projection of the impact. So you can identify the areas that need to be evacuated, how to evacuate them, how to get into the people that are there. You don't see very often to see persons in distress. You generally either know because they called you on the phone or because you know those areas are cut off and to go look for them. What surprised me was Fort Bend County was really interested in livestock in distress because they have a lot of expensive cattle out there. I think there's several stud farms, so they were really you don't want those herds to be lost. And that had been a terrible loss in Katrina. Nobody had thought about the animals, and that had been a problem. Also, and Fort Bend was able to start estimating the types of debris, how much was going to come from houses, how much was going to come from trees and vegetation, which impacts your estimates of your cleanup costs, what kind of contracts you're going to contract, and how much you're going to contract for, and try to get the good dump trucks and get them fast. So, next slide. Also, a big one was verification of flood inundation models. So that's, of course, helping to project the impact. But you've got this model, and having the experts on hand who could just look at what they were seeing in the image and spot check it against what that nice paper map was saying. But they could also go with visual landmarks. Oh, that big oak tree over there, yeah, it's touching it. Yeah, that's exactly about right. Okay, and then as I said, in some cases, let's go zoom up this. Here, go zoom up this creek, fly up this creek, so we can see why this is not flooding the way we think. Or let's go document the development, which has kind of screwed up the drainage and will need to be fixed later. Next slide. Okay, in flood monitoring, I said another big surprise to me was the idea that flood gauges get washed away. Keep being able to monitor the flood and how that's actually changing and how fast. Next slide. Another surprising mission, I think surprising that, is both for the publicly accountable decisions and public information. During the April and May floods, what was happening during the April 2016 floods, a lot of people from out of state were calling 911 in Fort Bend because there's a senior assisted living complex right there on the river. And they're, of course, worried about grandma. Is she going to be okay? And unbeknownst to us, now, in the meantime, Fort Bend was taking every video. Their UAS policy is hey, look, we promise. What we're going to do is that we're going to take all the UAS video, we're going to screen to make sure there's no PII, personally identifiable information there, anything bad that would be uncool to put out. If that, we're going to post it to Facebook. You see what we see unless there's some reason, a good reason not to. And so they were doing that, and emergency management was posting that. And what no one realized was the 911 dispatchers had noticed that, and they were sending people who are calling about that senior assisted living to go look at the video we had taken of the river right through there, because you could see very clearly it wasn't going to get flooded. It really wasn't in any big danger. And after that, after 2 weeks later, Fort Bend realized that was happening and said, okay, let's try to do this more systematically. Everybody, all you agencies, know we're putting this stuff up. Use this, point this to people. Now, during Harvey, the county judge, which is in Texas, is the chief executive officer, basically, of the county, was having morning 8 a.m. and 5 p.m. on the news shows giving a short brief. And he was monitoring social media. And one of the big mega neighborhoods were saying, so-and-so says our houses aren't flooded, but we're still evacuated. This isn't fair. Why can't we go back in? This is terrible. So we got stopped, and one of our teams had to go out and fly that neighborhood. Came back, the video, and then he was on the news saying, hey, look, yeah, you can see, you're right. These houses are not flooded, but it's flooded all the way up to almost to the front door, to the yards. And because we use the streets are designed to be the drainage. Well, look at that little square you're seeing in the middle of that water. That's the top of a pickup truck. So that's how deep it is. And see that yellow slick over there? That yellow, that's actually raw sewage that you would have to be boating through or wading through to get to that, which is a total health hazard, and it's a face-eating bacteria situation. So that's why we've got the evacuation order in place. Until it goes down enough and we can clean some of that up, it's such a health risk to get y'all back in there. And then, the next day session, okay, well, Corps of Engineers need to drain this faster so we can get back in. So it was really a positive view. Nobody, and there were no complaints about the use of unmanned aerial systems. They were being used by the county, by county personnel, from county vehicles, this sort of thing, and all the data was going immediately there and being used to help them make both the managers make decisions, but also to make it publicly accountable. Okay, so next slide. So at this point, I hope you are believing that, yes, small unmanned aerial systems for $1,000, I can do great things with them. But there's always going to be a trade-off. There's always no free lunch. So what are those hidden costs or surprises? Next slide. Okay. Probably not a surprise, is that you can fly and coordinate with manned aircraft, right? I mean, the military's been doing it for 10 years. So this is not a huge surprise that we can actually do it inside the continental U.S. What's probably the bigger surprise is like at Harvey, it's like, oh, wait, it's raining cats and dogs, so we can't fly due to the weather. So do keep that in mind. You can't always fly just because you want to. Next slide. I've already talked about the positive, the resonance of that. What we find is that if you just send a UAS team out in jeans and a t-shirt, not such a good reception. If I'm out in the field, what happens is I swear local residents assume that I am a producer from CNN. We're some sort of news crew that are there to profit off their suffering, which is terrible. I mean, it's horrible to think people would do that, that people would exploit other people. And I understand why they're mad. But if you go, so we quickly learned that if we go with someone in the county truck or the American Red Cross, someone with an official vest, and we're wearing official uniforms, they can say, we're with the county, then it's like, yay. And then we get inundated with, well, so-and-so has diabetes and he hasn't had his insulin, his leg's really swelling up, and we can't get hold of any paramedics, what do we do? And then different things like that. And so what Fort Bend did at Harvey was actually, for the first couple of days, embed social workers with the UAV teams to go out with them so they could answer all of those questions. Because having a drainage expert and a UAV pilot say, wow, that really sounds terrible, here's this 1-800 number call, or I promise to tell somebody when we get back, is not particularly meaningful. I mean, and it's all we can do. So if you start embedding your representative there, it really helps a lot. And again, it makes people very proud of their municipality for doing that. You know, clearly using good technology, the UAVs, to help solve the problem, have people there to help them. They're reaching out to different parts of the county. Okay, also, let's just go back. The data also impacts, immediate threat versus a hailstorm. So what we've seen is that some insurance companies have gone like after hailstorms and asked for special permission to go in and fly, and people are like, what the heck? We don't care. That's just you trying to save money, even though they're paying insurance, right? They like their counties. They like public officials in doing the right things. They're not so worried about anybody else there. All right, next slide. Other gaps. All right. There's a lot of data you're going to get, the informatics, and it's not always easy to understand. You know, you've got a 20-minute video of which maybe 90 seconds is valuable to somebody else, and a different 90 seconds may be valuable to somebody else. Streaming isn't always a solution, because then you just get everybody in the operations center staring at the pretty pictures instead of doing their job. So really that's on us as researchers, university researchers, to try to create more tools that make it easier to use and manipulate the data. Next slide. And so this is a case where, again, just sending out UAV pilots and say, go figure out what's going on and get the data back to us actually saves you no time. This is a picture of one of the bridges over the Brazos Valley, and it could have some damage, but the pilot managed to, and there's a whole video of not capturing quite the angle that you needed as a civil engineer to make a decision or not. It's just enough to suggest that there's a problem. So you imagine, like I said, Harvey, 2 to 4 hours to get out. You're talking hours to get to that site. You can't stream if the cellular's down, high priority, low bandwidth, you're not streaming it back to that civil engineer. Now you have to take it back on a thumb drive. So now what, you're 4 hours of time only to discover that you've got to go back and refly it. And that's why it makes sense to have your experts embedded in the teams. They can see, they can get the better view. Let's go to levee inspection. Same thing with levee inspection. So the levee board, if you look at the lower right, they're like, we don't actually need a UAV to tell us that the water has overtopped. We can figure that out on our own. What they really need is to catch it over in the upper left. When you're looking at that water over in that drainage ditch could either be water in a drainage ditch from drainage, or it could be seepage, which is really common for that kind of levee to go with seepage underneath and undermining the levee. And that's something, it's really hard to train UAV pilots for that. You just need somebody to look, and then they'll probably want to look around some more and get a different angle. So it's really nice to have that embedded expert. Okay, next. Also, your GIS branch, whoever's running your planning branch or GIS branch or any of your managers, they're never extra time. They're not sitting around with nothing to do during a disaster. So they're not going to be able to absorb trying to figure out 150 gigabytes of data in 600 files. Well, actually it was close to 7,000 images, but you're just looking at the number of file folders. Okay, so you're going to need somebody back at the base whose sole job is to manage it. And what we now do is that when we go to the field, we try to have 2 people just to do that. They're doing backing up the data, renaming it because image 001 is not really helpful. So at some point you can get a folder that says it's from this location. That 20-minute video, that 10-minute video, getting the right 90 seconds. Uploading, if you're doing any kind of photogrammetric mapping, you're probably going to a cloud service, so you've got to upload it, monitor and make sure the upload didn't kick out, restart it, threaten the network, sacrifice a chicken, those things, get it, then download it, let everybody know you now have the map so they can go look at it, otherwise they'll forget about it. Next slide. And again, there's lots and lots of data. So when you think about 800 images to get one of those orthomosaic maps, and it can take 8 to 24 hours to process. You can see why you don't try to do it at the very beginning. You're not going to get it back fast enough to make a decision. And so again, universities are looking at how we can push it down to the edge to where it would actually run on the UAV or the UAV controller, so it'd be faster. Next slide. What's still one of the biggest problems is getting the right information to the right person. So in the Louisiana floods in 2016, we were out and had beautiful high-resolution imagery, and one of the experts with us said, oh, if I could only show the incident commanders this, they'll totally understand the situation, they'll be able to do blah, blah, blah. And they said, oh, okay. I said, give me a minute, I'll edit it on the laptop, which was going to take about 20 minutes to do. And they said, no, this is easy. I don't need it at that higher resolution. He just played it on the laptop and did it with his phone, and then he already had his email list of people he wanted to see. He just had to hit one button, send, right? We were going to have him to enter in all the new email addresses on, and so that's one of the problems that we have right now. So it's not quite as simple to use as we'd like, not as seamless for our managers. Okay, next slide. So we've got that informatics, getting the right information to the right person at the right time. And so that's something that you may not have thought of, and that is going to increase your manpower. Both you need that agency expert with the teams in the field, at least for the response phase, so they can see what they need to see without having to send the team out with losing 8 hours, 4 to 8 hours, and going back and forth. And then that embedded data manager, and you may actually consider, if you've got teams out in the field, to have a courier just physically go out and grab that imagery and bring it back, just running laps to speed that up. Next slide. So hopefully what you've taken away from this is that small unmanned aerial systems are cost effective, and everything I've shown you except for flying at night with thermal, you can fly at night with the DJI Mavic Pro. Everything you can use with a $1,000 platform. So that's great. They're cost effective. You can use small unmanned aerial systems before, during, and after. And again, emphasizing that, remembering to embed experts with the small UAS teams, and just to be on the alert for the hidden cost of data management. It's all manageable. It's just not a great thing to discover, 18 hours into the disaster, that you don't have enough people and it's really stressful and you're beginning to drop balls and losing data and can't find what you're looking for because you didn't plan ahead. Next slide. We pulled all this together on the crasar.org website. We like to do these one-pagers, and here is a summary of the small best practices for small unmanned aerial systems for floods. We have more and others, and let's go to the next slide. And as you start using these unmanned aerial systems, please let us know, because we'd love to learn from you and continue to add to our databases and lessons learned. And so we really, really want to hear from you on that.
All right. Thank you, Robin. Are there any questions from the audience now regarding Robin's presentation? If you have any, feel free to just type those in the chat pod there.
I see Doug W. is typing, I hope, and he had earlier typed audio faded, hard to hear. Hopefully he's not asking for a redo of the whole presentation. So.
All right, Robin, the question from Doug is, do you usually contract out to UAS organizations?
I'm not sure exactly what you mean by contract out. The CRASAR nonprofit, we're volunteers. We are called by agencies. We do not deploy unless we have an official invitation because of legalities, right? The Good Samaritan laws, and to be under their ordinances, and also FAA regulations, everything there. So we are volunteers. We are happy to get paid, to get our travel costs paid. A lot of time we're working, CRASAR is anchored by Texas A&M and Florida State University, and we're always getting grants to kind of pay for that. But there's been times like the Mine Safety Health Administration and other agencies have actually put us in advance and put us on there where we could get our travel costs recovered, and to count it as a recoverable cost from FEMA as well. So the UASs are becoming tight, so that can be done depending on what state you're in. Did that make sense? Did that answer your question, Doug? Sorry.
Yeah, and then Doug, from the agency perspective as well, we've talked with a lot of state agencies, and they tend to fall in between, where they'll contract out some work to UAS and also do some in-house. So if you're coming from an agency perspective, one thing that agencies tend to rely on contracting out is keeping up with technology and innovation. That can be overwhelming, and so sometimes you leave that to the contractors, and the most advanced technology that you don't need to do your routine UAS work, you can do in-house as well. So that's kind of the agency perspective.
Yeah, hey, and let me just amplify that. I've got a whole little webinar about volunteering and stuff. This is working in a disaster is very different than flying for, uh, as a real estate salesperson, getting pretty pictures. Our agricultural response. I mean, the airspace regulations are usually quite different. You are flying under duress. You have to fly with a much smaller crew of people. You've got to have a much lower footprint. You're in adversarial conditions. I mean, the number of insects and critters that were uncool coming by, things. All of these things, it's not really for people. You can be experienced at UAVs and not experienced at both the conditions you're going to be flying under, the really constrained launch and landing sites that you get. You don't get to wave off certain flights. You just have to get it out. And it really requires a great deal of experience. And so I always cringe when people are saying, oh, I'm going to get people to volunteer. And it's kind of like, ah. And so we're trying to work on, we have training classes for responders to talk about exactly that sort of thing. We offer a 4-day class.
And then there was a question from Dale about if this presentation is available. And yes, it will be made available on the same website that I posted on one of the previous slides. You can also email me, Caitlin Friesman, so my email address is on this webpage if you aren't able to track it down. But that will all be on the same website. So you can access the future webinars once those are done. And again, that's the link to all the material from the summits as well.
And to answer Dale's question, we normally fly under an FAA 107. There have been cases where we've flown under a COA. There's some blanket COAs, but remember what are generally the FAA 107 rules can change a bit. Michael, the FAA decided, they said, okay, we're not going to do TFRs anymore. They're really hard to coordinate with small unmanned aerial system teams. We're just going to say 200 feet, the TFR on manned aircraft and anything affecting helicopters will be 200 feet and above. So it was kind of like the wild, wild west on Mexico Beach. We were the group flying for the state of Florida under the direction of Bay County, and there were a lot of extra people flying UAVs, and we almost had two accidents, incursions, and then we watched one of the UAVs from the press, the major press agency, fly, I mean, totally nonsensical as a manned helicopter was landing, like the worst point in time, right? If there had been any kind of collision or if it had spooked the pilot, that was, yeah. So yeah, 107 seems like it'd make it simpler, but yes, everybody has a 107 license.
All right, so I'll give a wrap up here. If you have a question while I'm talking, feel free to type that and we can address it. But there's 3 contact information listed on the slide here. The first is Robin's email address, so she is a great contact if you have emergency response related, specific subject matter questions. Those would be directed towards Robin. James Gray is the lead from FHWA for the EDC-5 UAS innovation. So if you have questions, if you're an agency wanting to get started on UAS or ramp up your UAS program, questions regarding that could go to James Gray. Again, anything related to implementation. And then webinar materials, future webinar dates, getting access to the presentation, any of that you can direct towards me, and my email address is given there. So since I'm not seeing any other questions, thank you all for joining us today, and thank you, Robin, for this presentation on UAS for emergency management of flooding.